Hello everybody, welcome back. Okay, let's wrap up solving rational equations here. I just wanted to do one that's got a little bit more difficulty to it than the ones we have encountered so far. So just note that you can find these questions, and if you can please do them for homework. They range from page 319 to 321. Just wanted to make sure I got that down there so I didn't forget to mention it at the end of the video. Okay, so this is on page 320. It's question number 4, and let's just get straight into it. So again, the first thing we want to do is just set the equation equal to 0. Okay, so I'm going to minus this to that side, and I'm going to add this to that side to get everything on one side, which gives us this. I've got 7 minus 4t all over 2t squared minus 9t plus 10. And then I'm going to minus that to that side. So I've got minus t plus 1 over 2t minus 5. And then I'm going to add this to that side. So I've got plus t minus 3 over t minus 2. And now that I've subtracted that to that side and added that to that side, we're just left with 0 on the right-hand side. Good. Okay, so the next thing we want to do is factor the denominators here. So as you can see, we've already got 2 of the denominators factored at this point. And so now I'm just going to work on factoring this denominator here. Now, this one we need to do by decomposition, but I figured I might just show you guys how to do it by trial and error here. Let's see what happens if we do it by trial and error. Well, if I were to do this by trial and error, if I were to factor this denominator, I would just start like this. Well, I know it's a quadratic. It's going to require 2 sets of brackets with linear expressions on the inside. And, well, I know the top 2 terms, the first term in each set of brackets, together they need to multiply to 2t squared. So it must look something like this, 2t times t like that. And then at this point, I know that the last 2 terms, well, they need to multiply to 10. So I just have to kind of think about what are the factors of 10 here at this point. Well, we've got 1 and 10 and 2 and 5. There aren't too many options here. Now they need to multiply to a positive number, and they need to add to a negative number. I know this much, so therefore they must both be negatives, whatever it is. And then I can just kind of do it by inspection. Well, let's say I try putting a 10 here. What am I going to get? I'm going to get 2t minus 10. That gives me minus 20t. And then if that was 10, that would have to be 1. Well, that's not going to work when I expand it back out. Okay, but then in my head, you're just doing this all in your head. I would say to myself, oh, wait a minute. If I put a minus 5 here and a minus 2 here, I would get 2t times minus 2 is minus 4t. And then minus 5 times t would give me minus 5t, and I'd add them together to get minus 9t. Okay, so that's one way to do it. I'm going to do the decomposition for you one more time here. So what do I have? I've got 2t squared. And we'll just do it off to the side over here. Well, I guess it doesn't really matter. I can just do it just about anywhere. I'll just do it over here. Okay, I've got 2t squared minus 9t plus 10. To be perfectly honest, I always do these by decomposition. Once you get good at it, it's really only 2 steps. Okay, now I'm looking for something that multiplies to 2 times 10, which is 20. And it needs to add to minus 9. And what works here? Let's see. Well, 4 and 5 work, but they should both be negative. So minus 4 times minus 5 equals plus 20. And then minus 4 plus minus 5 equals minus 9. And now we can just go into the decomposition. Got 2t squared minus 4t minus 5t plus 10. If I decompose that minus 9t like so, and then I can factor by grouping. Here I've got a GCF of 2t. Here I've got a GCF of minus 5. And at this point I can honestly see what the factorization is, and that's why I just kind of stick with decomposition for these ones. Okay, so if I factor out a 2t, I'm left with t minus 2. And then if I factor out a minus 5, I'm left with t minus 2. And then altogether we've got the common factor of t minus 2. Factor that out, and we've got 2t minus 5 left over. So that's the factorization of that first numerator. Or denominator, sorry, the first denominator. Okay, let's put this all together now. Alright, so what's my equation look like at this point? Well, I've factored that denominator, so I've got this. 7 minus 4t over 2t minus 5 times t minus 2 minus t plus 1 over 2t minus 5 plus t minus 3 over t minus 2. Okay, now we need to build our common denominators. All right, we're just at the adding our rational expression point here. And at this point, you can see the LCD is 2t minus 5 times t minus 2. And therefore, I should multiply the top and bottom of that by t minus 2 and the top and bottom of that by t minus 5. And all together, I'm going to kind of streamline the steps here. Okay, our LCD is 2t minus 5 times t minus 2. Well, instead of multiplying it in a few steps, well, I guess I could do it here. Okay, so again, I need to multiply the top and bottom of this by t minus 2. And then I need to multiply the top and bottom of this by 2t minus 5. Okay, and all together now we've got the common denominators. So I'm just left with this. Okay, they all have the common denominator, 2t minus 5 times t minus 2. And then this one is going to give us a 7 minus 4t. And then here we've got minus t plus 1 times t minus 2. And then here we've got plus t minus 3 times 2t minus 5. And this all equals 0 still. Okay. You know, we talked about the fraction rule at the beginning of the last lesson. The property star. I called it property star because I wanted to reference it as property star, but then I never ended up doing that. But I'm going to use it right here, right now, just to save some writing. Okay, so property star just said this. If a over b equals 0, then it must be true that a equals 0. In other words, we can just get rid of the denominator. So at this point, I mean, look what we've got. We've got a single fraction. It's equal to 0. At this point, I can just get rid of this denominator. Okay, and really what we're doing is we're just multiplying both sides by that to cancel it out. But 0 times that is going to be 0. Okay, so I'm just going to get rid of that altogether at this point. And I've got this left over. Got 7 minus 4t minus, I'm going to use an extra set of brackets here, So I'm going to end up needing to distribute that negative once I expand those two brackets out. Okay, plus t minus 3 times 2t minus 5. And this all equals 0. Okay, so what do we have here? Well, chances are we're going to have a quadratic equation. All right, I'm going to FOIL that out, which will give me a t squared term. I'm going to FOIL this out, which will give me a t squared term. And then we'll be left with a quadratic equation to solve. So I'm just going to start a new piece of paper here. Okay, so let's start foiling this out. I've got 7 minus 4t. I'm going to keep that minus there, and I think I'll just do this in my head. Okay, so I've got t times t is going to give me a t squared. And then what are we going to get in the middle here if I expand this out? Well, I'm going to get plus 1t minus 2t, which is just going to leave us with a minus 1t. And then I've got plus 1 times minus 2. This is equal to minus 2. And that's what we get for that one. Okay, and now I'm just going to expand this out in my head. T times 2t is plus 2t squared. Minus 3 times minus 5, that's going to be plus 15. And then for the middle terms, I'm going to get a minus 5t minus 6t. Minus 5 minus 6 is minus 11t. And that's what we're left with at this point. So make sure to distribute the negative sign. And then we'll start collecting like terms. Remember, when you solve a quadratic equation, at least up to this point, we're going to learn new ways to solve these equations before the term is up. But for now, it's just by factoring. Okay, we need to factor. Okay, so let's get rid of that now. So let's distribute the negative sign and collect like terms. I just get 7 minus 4t. And I apologize for the lighting. Obviously, I noticed this, but yeah, it's too late to turn back at this point. Then if I distribute the negative, I get minus t squared plus t plus 2. And then I still have the plus 2t squared minus 11t plus 15. What I'll do is I'll pause and step back for a moment just to give it some extra light. It looks so beautiful like this, doesn't it? And of course, the poor light conditions here are not helping the situation. Okay, now let's collect like terms. Let's start with the highest power of t. Well, I see I've got minus t squared plus 2t squared, which is just going to leave me with a t squared. And then we've got the t terms. Let's deal with these. So what do I see here? I've got minus 4 plus 1 is minus 3. Minus another 11 is minus 14t. Okay, and last but not least, what do we have? We've got 7 plus 2 is 9, plus 15, is that 24? 15 plus 9 is 24, yep. Plus 24 equals 0. Okay, and we're almost there now. We just have to factor. So, again, do the decomposition here at home if that's the way you feel comfortable factoring these. But again, we're just looking for something that multiplies to 24. And it it needs to add to minus 14. And of course, that's just minus 12 and minus 2. Okay, so altogether, the final factorization of this is t minus 12 times t minus 2. Good. Okay. I absolutely promise I am not going to have any more lighting problems from here on out or anything like that. Obviously, I've come to the conclusion that this works best at certain times of the day. Obviously, I could just turn on the LED here, but I don't like the pencil marks seem to pick up the LED quite well. So anyways, let's just finish this off, and then we can almost call it a wrap on this unit. We'll have one last thing to cover. Okay, now using the zero product property, this one gives me t equals 12 as a solution, and this one gives me t equals 2. Does anybody remember what our LCD is? Well, our LCD was 2t minus 5 times t minus 2. Our LCD was 2t minus 5 times t minus 2. Look at this, those factors match. Yeah, you guessed it. This is a valid solution. It's a valid solution. And this here is an extraneous solution, or an extraneous root. Ah! It's an extraneous root. Okay, and why is that? Well, again, if you look back at the original equation, if you let t equal 2 be one of the roots, it's going to give you division by 0, which is undefined. So that's why we remove that. We remove that solution from our solution set. Okay, good. I hope this has been helpful, and I'll see you for the next video.